Okay, so this video we're going to be going over some of the more common mistakes on the math review. And if you have any further questions, please feel free to come in and see me during your study hall, my prep period, and we'll get all these things worked out. So the first one that I'm going to kind of get dropped down right to is the ball to the first one here. It rolls 0.89 meters. So that's what we're told. And we want to convert it to centimeters. So I have 0.89 meters, and I want to set up a conversion. So when I set up my conversion, if I want to get rid of meters, I'm going to put meters down below, and I'm trying to get into centimeters, so I'm going to put centimeters up above. Now, some of you are getting used to using, moving the decimal place, and you might use the Atlantic to the Pacific rule. And if it's working, fine, but if it's not, please, utilize this. The way that I answer this, I ask myself, which one is larger? And so in the case of the centimeter and meter, the meter is larger. So that tells me which number to put a 1 next to. The larger number you put on a larger unit, you put a 1 next to. And since centi, if I look up in my reference tables, centi means times 10 to the minus 2, or in other words, 100th. So that means that there's 100 centimeters in 1 meter. And if I multiply these two values, then I just get 89 centimeters. The other problem that people had some issues with was the wavelength of the red laser. So if I have a laser that has a 670 nanometer and I want to get into meters, well, I'm going to do the same thing. I'm going to put nanometers down below when I'm trying to get into meters. Now, if you look at your reference tables, nano means 10 to the minus 9. So these two are equal. So that tells me that it's less than the meter. So the meter is the bigger number. So I put a 1 next to that, and then I'm going to say that there's 10 to the 9th, positive 9, because there's got to be many more of these to make one of those. And if I divide these two numbers, I would get an answer of 6.7 times 10 to the minus 7 meters. Okay. Now the next one, it was the download the file. So if I'm downloading at a 4 megabyte file at a rate of 50 kilobytes per second, how much time do I have to wait? So what I want to first do is, and I suggested, is let's convert megabyte to kilobyte. So if I'm trying to get rid of the megabyte, I put megabyte down below and kilobyte up top. And I look up, mega is equal to times 10 to the 6th, and kilo represents 10 to the 3rd. In other words, there's 3 powers of 10 between them. And since mega is a bigger number, there's going to be one of those, and there's 3 powers of 10 between the two, meaning that there's got to be 10 to the 3rd kilobytes in 1 megabyte. So if I multiply these two out, I have a 4,000 kilobyte file. And then I want to divide that by my 50 kilobytes per second. So we get that 0 cancels out with that 0, and we get 400 divided by 5, or 80. But if we look at the units, we have a kilobyte divided by a kilobyte per second. And if you remember how you divide fractions, copy, change, flip, this is equal to a kilobyte. Copy the top part, change this to multiplication, and then flip the denominator. And if I multiply these two, my kilobytes cancel out, and I'm left with seconds, which is good because I was looking for a time. The next one that people had issues with was the ratio of the mass of a proton to that of an electron. So I want to look up what the mass of the proton is, and then I want to divide that by the mass of the electron. And if you look up the mass of the proton, you get 1.7 times 10 to the minus 27 kilograms. and then the mass of the electron to be 9.11 times 10 to the minus 31 kilograms. And the kilograms cancel out, and if you do this in your calculator, you get 1,830. And notice I rounded it to 3 sig figs. Actually, I'm going to round it once more, 1,800. And there's no units. It's 1,800 to 1, meaning that the mass of the proton is 1,800 times larger than that of the electron. If we look at number 2, we have K equals 1/2 times m times v squared. And we're asked to solve for v. So we have to do a couple of different things. I want to first get rid of this 1/2. So you have to ask yourself, what is the opposite operation of multiplying by a half? You can answer one of two things. You could say, I divide by half, or you could say, I multiply by 2. So I'm going to multiply by 2, because if I multiply by 2 on this side, that cancels that out to make that 1, but I got to multiply by 2 on that side. So now if I rewrite it, I have 2 times k equals mv squared. And I want to get v by itself. So I'm going to divide by m, and then I'm going to square root both sides. So v is equal to the square root of 2 times the k divided by m. And if I go ahead and plug in 1,600 for k, that is 2 times 1,600 divided by my m of 200, I would get a v of 4. And that's actually meters per second. We'll talk about later how that works out. Likewise, with number 3, if I'm trying to solve for r, I'm going to rewrite the equation without the slash, and I'm going to write it as a true fraction. If I want to get r by itself, it's in the denominator. I have to first get it in the numerator, meaning I have to first cross multiply. So my first step is cross multiplying, so I get p times r equals v squared. And then my next step to get r by itself is then divide by p. But nevertheless, I get v squared divided by that p. And if I want to plug in these numbers, r equals v squared, and if v is 10, then I have 10 squared divided by p of 200. Then 10 squared is 100, 100 divided by 200 is 0.5. And don't worry about the units right now. If I want to get v by itself, okay, I have to first cross multiply by r. So v squared equals pr, so same thing that we had down here. But then to undo the squared, I square root. So v equals the square root of p times r. And if I plug in 12.5 for p and r a half, I get a v of 2.5. And what we can do is we can then go back to see if the values are correct. So going back to the original part, okay, power p equals v squared over r. Let me see if I put in that r with that v, do I get that p, the 200? So the question is, does 200, does it equal 10 squared divided by a half? 10 squared is 100. You divide by half, 200. 200 equals 200. So that does work. So we can check it. Now, if we look at the last one, we have v squared equals u squared plus 2as. And I want to get a by itself. So when I'm undoing an equation, I have to work in reverse orders operation, meaning I have to deal with the addition before I could deal with the multiplication. So to get a by itself, I'm going to first subtract u squared from both sides. U squared minus u squared is 1, so that cancels out. There's going to be 0, so that cancels out. We have v squared minus u squared equals 2as. And then if I want to get a by itself, I could divide by 2s. Divide by 2s. 2 divided by 2 is 1, and s divided by s is 1. So I get an expression, a equals v squared minus u squared over 2s. And if I'm plugging in values, I have a v of 3, so I have 3 squared minus 1 squared all over 2 times 0.25. So 3 squared is 9. 9 minus 1 squared is 8. So this is equal to 8 divided by a half, 0.5. So a equals 16. And once again, we're not worrying about the units for right now. If I wanted to solve for u, okay, I'm going to rewrite the original equation, v squared equals u squared, that's a u, plus 2as. Well, what I have to first do is subtract the 2as, and I get v squared minus 2as equals u squared. And then what people forgot to do is I have to square root both sides in order to get u by itself. So u equals the square root of v squared minus 2as. And if I plug in numbers, I get the square root of 3 squared minus a 2 times a negative 2. The negative 2 is the a, and then an s of 4. So that equals the square root of 9. A negative negative, that turns it into a positive. 2 times 2 is 4, and 4 times 4 is 16. And so this is radical 25, which is equal to 5. So those are the ones that kind of stood out to me of the ones that people missed the most. But if anything on here or anything that's not on here, you have some further questions, please come and see me. The schedule's posted outside the room, and thank you for listening. Have a great night. Bye-bye.